Transformed random variable. Given the PDF of x, determine the PDF of y of some function. In this type of problems, first we are going to find the CDF of y using the definition of CDF. Then we are going to differentiate CDF to find the PDF of y. Let's begin. Density function of given random variable is normal random variable. Normal random variable x normal with parameters mu, sigma squared is normally 1 over sigma times square root of 2 pi e to the negative 1/2 x minus mu over sigma, the quantity squared. And in our problem we were given x standard normal with parameters 0 is the mu and 1 is the sigma squared. That is the definition of the standard normal variable. And if you plug in mu as 0 and sigma as 1, you're going to obtain the density function of x standard normal, which is fx of t, 1 over square root of 2 pi e to the negative t squared over 2. And this is in the entire region from negative infinity to infinity. Now we're going to solve this problem by starting the definition of CDF. CDF by definition is the probability that y is less than or equal to t. Let's see the relationship between x and y in our problem. We were given that y is equal to absolute value of x. So if y is equal to absolute value of x, then we can rewrite this probability that absolute value of x is less than or equal to t. Therefore, fy of t is equal to probability that absolute value of x is less than or equal to t is probability that x is between negative t and t if t is greater than 0, and 0 if t is less than, by the definition of absolute value of x. And we know that absolute value cannot take the negative value, so if t is less than 0, then it is 0. And we know that probability that x is between negative t and t is the integral from negative t to t of the density function of the random variable by definition of probability. So we can rewrite this integral as integral from negative t to t of the density function of our standard normal, 1 over square root of 2 pi e to the negative s squared over 2. We use the dummy variable here, ds. Now, antiderivative of standard normal random variable is the phi function. So we can write it as phi from negative t to t. So this will be phi of t as our upper boundary minus phi of negative t as our lower boundary. And phi of negative t, the properties of phi function is 1 minus phi of t. So if we rewrite this as phi of t minus 1 minus phi of t, it will be 2 phi minus 1. So we can write CDF of y as two phi of t minus 1 if t is greater than 0, and 0 if t is less than 0. Now we found the CDF of y. Our second step is to differentiate the CDF to find the PDF of y. So derivative of phi function is the density of standard normal function, which is 1 over square root of 2 pi e to the negative t squared over 2. And antiderivative of standard normal is phi function. Derivative of phi function is the standard normal. So our density function fy of t is equal to 2 times the derivative of phi function, which will be 2 over square root of 2 pi e to the negative t squared over 2 if t is greater than 0, and 0 if t is less than 0. So this is the PDF of y.